wasn't that hard. All right. Haley's going to do A for us. Whoa, too far zoomed in.
Why is it so close? Oh my gosh. Hello.
Hey there, Zachary.
Miss Well. Dude, that last stick? Why'd you hammer out? Yo, what? What'd you get at first name? Weird.
Amber? No, lots of kids call me Amber. Really?
Oh, that's weird too.
Do I not look like an Amber? I don't like my first
It just feels wrong to call a teacher by their first name.
name. Elise.
Oh my gosh!
I like that one better.
That's
Hey,
almost
Jeff.
like my name.
Jeff is such a
It was supposed to be Elise, but my sister's Alicia, and my mom thought that was
At least you weren't named like,
I wouldn't Elise.
like something old,
I mean,
like
James.
my sister lives 12 hours away in the
Yeah,
other state, so I was talking to her, and she goes, oh,
First
Amber.
name?
I'm like, it's not even like Alicia's around, Mom.
Timothy.
something like that.
Yeah.
Yeah, like
Edward.
future people are gonna think like I've never met an adult named Noah. To be honest with you.
Noah was on my short list when I was pregnant with my last one. I like the name Noah.
Dude, my dad was trying to name yours and my mom was like, nah. I was listening. Every time you said a bad name, I was like,
Wait, how okay,
I don't like that name.
That's great. Did I answer your question? I came over here and stopped by you because you have good. Okay, good.
Noah. I've never met an
You're an adult, aren't you? Aren't
Okay, now I'm talking about like an older person. Like I've never met. I don't think.
I'm trying really hard.
Yeah, that's.
Yeah,
But I.
It's because it's like
well, then you
generations.
go up,
Right
then
now.
it's good. It's like
Like how old names are really common, like John.
Yeah.
Not a ton of people named John.
Or Michael.
they call her
Mine
God.
was pretty popular.
Yes, for adults right now. My neighbor's name is Michael. My husband's name is Michael.
My dad's name is
See?
Michael Clark.
Oh, yep, there you go.
I cannot stand him.
Bro,
I have beef with Mr. Clark.
you have beef with Mr. Clark? Bro, he's so nice.
I have beef with Mr. Clark too, being honest.
Oh, whoa.
All right. Yeah. So, null hypothesis is just that the distribution outcomes on the wheel is what it should be. You could have said something like the claimed distribution is correct. The alternative, the distribution on the wheel is not what it should be, or the claimed distribution is not correct. To find the expected counts, Shelley showed us that she took, where is it? Tells you there are 38 slots, 18 are red, 18 are black, 2 are green. So the proportion of red should be 18 out of 38, or 0.4737. Same for black, 18 out of 38. Green should be 2 out of 38, or 0.0526. So when we spin the roulette wheel 200 times, we can take those decimals times 200 to get the expected counts of red, black, and green. So she took 200 times the 18 out of 38 as a decimal, which gets you 94.74. Same for black, because red and black are both 18 out of 38. Green is 2 out of 38, or 0.0526. And 200 times 0.0526 is 10.52. Questions? So today we're gonna do some more chi-square goodness of fit. But before we do an example of that, we're gonna talk about the chi-square distribution and some characteristics of it. So can I flip? All right. So we've learned quite a few distributions. We used normal distributions when we worked with 1-prop or 2-prop z-tests. I don't know why I should have done 1/2 prop z-test, but I did 1-prop/2 prop z-test. I don't know why. That made me write more than I needed to. T distributions when we worked with 1 sample and 2 sample t-tests. And now we're going to use a new distribution, which is the chi-square one. And just as a reminder, chi-square. And we're going to use that. There are 3 different tests that we use the chi-square distribution for. The one that we looked at somewhat yesterday and we're going to continue with today is chi-square GoF, which is the chi-squared goodness of fit test. Then we will also learn chi-square test of homogeneity. I don't know if I say that word right. It's a good thing Nate isn't here to correct me. Homogeneity.
The last one was
Homogeneity.
I think so.
That's what I think, but who knows? And then, well, actually, somebody knows. Not me, though.
Probably me.
Probably me. And then chi-square test of association, also known as the chi-square test of independence. So I always just put association/independence. Today we're just going to focus on GoF, though. So, picture, I already talked about this yesterday. Chi-squared is in the first quadrant only. Starts at the origin, you have the majority of the data right there, and then it skews to the right. Now, that is true. There are a few exceptions to the rule. This is your chi-square distribution when your degrees of freedom are greater than or equal to 3. It looks different if the degrees of freedom are 2 or less. Still in the first quadrant, still starts, well, not really at the origin. It's almost like it's concave, right? No, I don't know. I shouldn't use words I don't know. This is for degrees of freedom less than or equal to 2. Greater than or equal to 3, we get to draw the peak, and it's skewed to the right. Less than or equal to 2, it's just kind of sad. Yes?
What's the P distribution then?
T. That's when we're working with means. And it's more, you have more area in the tails. Let's see, I don't have blank spots. We'll just draw it here. It's more like that when your degrees of freedom are small. And then as the degrees of freedom get higher and higher, it becomes more normal and more normal. So you get more normal. The biggest thing is with a T distribution, sorry, the centers don't match up. With a t-distribution compared to a normal distribution, you have more area in the tables when you have a small sample size. As the sample size gets bigger, the degrees of freedom get bigger, and so it becomes more normal. But t is used with means, normal is used with proportions, and now we have chi-squared. Any other questions before we go down here? I suppose I should technically put the zeros there so we know we're at the origin. No questions? Right. So, our nice characteristics of the chi-square. So, chi-square distributions are a family of distributions that take only positive values. So remember yesterday we took the observed minus expected and squared it so that we were dealing with only positive values. It's skewed to the right as the picture shows. A specific chi-square distribution is specified by one parameter only, which is called the degrees of freedom. So with our normal curve, we'd put the capital N with the mean and standard deviation. When we draw our chi-square distribution, we only have to put the degrees of freedom next to it. Degrees of freedom is found by taking n minus 1. N is the number of categories you're looking at. So yesterday with the Skittles, there are 5 colors of Skittles, 5 categories. And so we did 5 minus 1. We were looking at degrees of freedom being 4. Certain properties that the chi-square distribution takes, area under chi-square is equal to 1. Each chi-square curve begins at 0, increases to a peak, and then approaches the horizontal axis asymptotically. I really shouldn't use words that I can't pronounce. That one I know what it means, but I can't say it. As the degrees of freedom increase, the distribution becomes more normal. The mean of a particular chi-square distribution is equal to your degrees of freedom. The mode, or the peak of your chi-square density curve, is at the degrees of freedom minus 2. Just like with our 1 prop, 2 prop Z test and the 1 sample, 2 samples T tests, we have certain conditions we have to check, which I kind of alluded to yesterday. Random. The data must come from a random sample or a randomized experiment. Large sample size. So this one, instead of normal, because it's not a normal distribution, we check that all expected counts are at least 5. And then independent, individual observations are independent. If you are sampling without replacement, like we were yesterday with the Skittles, we check the 10% condition, which is that our sample size is less than or equal to 1/10 of the population. Two warnings I have for you. The chi-square test statistic compares observed and expected counts, not proportions. We do use proportions to help us find those expected counts, but we should be working with the counts, not the proportions when we put the data in there. And when checking the large sample size condition, make sure you look at expected counts, not observed. That's another common mistake, is kids say, oh yeah, all the observed are greater than or equal to 5, but we want to make sure expected is greater than or equal to 5. Any questions before we do a GoF test? Can I flip? See a couple people still writing, so I'll wait just a second. Do a little dance. Okay. So, according to the 2000 census of all U.S. residents aged 20 and older, 19.1% are in their 20s, 21.5% are in their 30s, 21.1% are in their 40s, 15.5% are in their 50s, and 22.8% are 60 and older. The following table gives the age distribution for a sample of U.S. residents aged 20 and older. Members of the sample were chosen by randomly dialing landline telephone numbers. Do these data provide convincing evidence that the age distribution of people who answer landline telephone surveys is not the same as the age distribution of all U.S. residents? It's like the third time you've dropped your pencil. You have better fingers today, don't you?
Yeah.
All right. Maybe stop twirling? No?
Yeah.
Are you a fidgeter? I'm a fidgeter too. All right, so we have the actual age distribution from the census. 19.1% are in their 20s. I think I'll use different colors so that they stand out a little. 21.5% are in their 30s. 21.1% are in their 40s. 15.5% in their 50s. And then 22.8% are 60 and older. So then they randomly dialed a landline number and they asked the age of the person who answered. 141 were in the 20s, 186 in their 30s, 224 in the 40s, 211 in their 50s, and 286 were 60 or older. So we want to see if this set of data provides evidence that the age distribution of people who answered landlines is not the same as the actual age distribution of all U.S. residents. So we're going to do a state plan do conclude. Let's see. I need to leave a little space here. How about we just do this first? Otherwise, I'm going to run out of space. So we have the age category. This count here is our observed count because that's the data they actually got. So I'm just going to label that count with observed above it. And what I want to make sure that I don't forget to give myself space for is figuring out all the expected counts. So I'm going to add a column to my table here and label it expected. You would think I would have thought through just adding an extra column here. All right, so we have the total number of people they called. That's at the bottom here, 1,048. We have the percents of ages for the U.S. distribution. So we're going to multiply those percents by 1,048 to get our expected counts. So 19.1% are in their 20s, so I'm going to take 0.191 and multiply it by 1,048. So we would have expected that 200.168 of the phone calls were answered by people in their 20s. Then I'm going to take the 21.5% times 1,048. The glare. And we would have expected 225.32 of the landline phone calls to be answered by people in their 30s. Then for the 40s, it's 21.1. So 221.128. Fifteen and a half are in their 50s. So 162.44. And then the last one, 22.8, 60 and older, so 238.944. And the total should still be 1,048. I'm not going to add them all together. It would be weird because I didn't even round. So it should add to 1,048 still. So now I'm going to do my state plan, do conclude. I just wanted to make sure I didn't write so big. I didn't have space to find my expected counts. So state, we need to give our null and our alternative and state our alpha level. So the null would be that the landline age distribution, so the ages of people who answer the landline telephone survey is the same as the U.S. age distribution. I'm going to paraphrase that somewhat. So landline, I'm going to use LL for landline. I'll draw a little arrow so we know it means landline. Landline age distribution. Same as U.S. distribution. U.S. age distribution, excuse me. The alternative is they're not the same. So landline age distribution, not same as U.S. age distribution. What's our alpha level? 0.05, unless otherwise stated. And that's all you have to do for state. Then we get to the plan where we state our calculator function and check our conditions. So our calculator function is chi-square GoF. We need to check random, large counts, and independence. So random, it tells us, where does it say? Randomly, they were chosen by randomly dialing. So we're just going to quote randomly. large counts, we have to make sure all our expected counts are greater than or equal to 5, which they are: 200, 225, 221, 162, 238. So all expected greater than or equal to 5. Independent. So here we're going to, because we're actually sampling, we're not putting the phone numbers back in to be chosen again. So we're sampling without replacement. We have to check the 10% condition. The sample size is 1,048, and when we multiply that by 10, we get 10,480, which is definitely smaller than the US population. Now we get to do, let's see, we need to draw our picture. So I guess I'll put it here. My conclude's going to be kind of funny because it's going to be off to the side. Sorry. So we're going to do we're going to draw our chi-squared distribution. What's our degrees freedom going to be? How many age categories do we have? We have 5 age categories, so our degrees freedom is 4, which means we have the peak and the skewness to the right. So it's going to look something like that. And the only parameter we put is degrees freedom is 4. Then we use calculator to do the rest, and we want to write down what the chi-square value is and what the p value is. Now, to do a chi-square GoF test, we need to put our observed and our expected into our lists. I suggest putting the observed in list 1, expected in list 2. So let's see, make this list 1 and this list 2. Do not put total in there. You just want the other. You don't need the total in your lists. Oops, what did I do? Edit. 141, 186, 224, 211, 286. 200.168, 225.32, 221.128, 162.44, 238.944. Everybody got their lists? So once we have our data in our lists, then we're going to go to Stat, go over to Tests. I think it's easier to scroll up to get to this one. We're looking for D chi-squared GoF test. We're going to hit Enter. Then it asks where I put my lists. I put observed in 1, expected in 2. Degrees of freedom are 4, so I need to change that. I'm going to have it draw it for me. There's my beautiful peak with the skewness to the right. And remember, I think I said this yesterday. When you draw it and you have a really small p-value, it just tells you 0. So sometimes, even though I like to draw it to make sure I don't have to shade anything, because we do sometimes shade our chi-squared graphs. Now I have to go back and hit calculate. First I'm going to write down my chi-squared though. It's 48.172. But to get a good p-value, not just 0, I need to calculate instead of draw. I don't know why. Well, I guess that's why, because it pretty much is 0. We have 8.69 times 10 to the negative 10th. So we have 9 zeros in front of that 8. So 8.69 times 10 to the negative 10th, which really is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I guess that's why it says 0. Well, it's so small, it pretty much is 0. Now we're going to conclude. The conclusion is just like our significance test conclusions. It's a little novel. We start by saying, assuming H null is true. We are going to write something in the box. I have it there for a reason. Some of you are like, why is she avoiding the box? There is something we're going to put in the box. So you might want to try, you can write a little into the box, but I wouldn't use the box for your conclusion. All right, so assuming H null is true, we're going to write the real one. It's been a while. Because on your test, you have to write the real one. So assuming H null is true, there is a 8.69 times 10 to the negative 10. I was thinking that was shorter to write, but I don't know. It's a bunch of things to write anyways. Anyway, sorry. Probability of getting a chi-square greater than or equal to 48.172 purely by chance. Is that strong or weak evidence? No, strong. Let's see. This provides weak evidence. Strong evidence, excuse me, against H null if we have strong evidence, is it statistically significant or not? Yes or no? Yes. And is statistically significant at alpha equals 0.05 because our P is less than alpha. Are we going to reject H null or fail to reject? Reject. Therefore, we reject H null and conclude what? The alternative, but you should say it in context. So we would say and conclude landline age distribution not the same as US age distribution. Anna didn't like that. Sorry, Anna. And conclude landline age distribution not same as US age distribution. Let's see, what color? We'll go with purple. All right, so down at the bottom, notice it says follow-up analysis. You only have to do this if your p-value is significant. So if you fail to reject H null, you don't need to state this part. But if we reject H null, we need to talk about our largest contributor. Sorry, I gave it away. To do this, we find the largest contributor to your chi-square value, which honestly is not hard. The calculator does it for you. I might have to. Can I cover it up with my calculator? So when I did the chi-square GoF test, gave me chi-squared, gave me my p-value, gave me my degrees freedom, and I didn't talk about this very bottom thing. This is the contributor. If I scroll to the right, it gives me 5 values because I have 5 age categories. So it's telling me how much each age category contributed to the chi-squared. So if I add those 5 numbers together, I get the 48.172. Those, by the way, those contributors are found, we looked at this yesterday when we did the observed minus expected squared divided by expected. I didn't actually have you do it yesterday, I just had you write it down. But we would do that, add them all together, and that's where you get chi-squared. So here, it's telling me that, sorry, I need to scroll back to the beginning. So the first contributor is from the age group 20s. 17.49 of our chi-square came from the category for the 20s. Then 30s was about 6.86. 40s was 0.04, not very much. 50s contributed about 14.52, and then the 60s contributed about 9.27. So our largest contributor was the first one. And the reason why the 20s has the largest contributor is because our observed count is furthest away from our expected. All the others are not as far apart as in the 20s. So your largest contributor comes from the one where your observed and your expected are vastly different than all the other ones. So you're going to make some statement, and this is what I saved the box for, was our follow-up analysis. Some statement about the largest contributor. So I'm going to say the largest contributor to the chi-square statistic is, and then I'm going to give the actual amount, but I am going to round. Let's go to 2 decimals, so 17.49. Because the number of 20-year-olds in the landline age distribution is much lower than expected. And like I've said, I'm not the greatest with words. I'm sure you guys can make it more concise than I did. But notice I gave the actual value of the contribution, and I explained why it's in the 20s, the age category for 20-year-olds. Questions? You guys want to try one on your own? Okay, well, I suppose we can do it together then. Amelia's going to love this one. Goes back to biology for you. And like I've said, if you take AP Bio, you use chi-squared. So it does have a lot of applications for biology. All right. Biologists wish to cross pairs of tobacco plants having genetic makeup big G, little g, indicating that each plant has one dominant gene, capital G, and one recessive G, little g, for color. Each offspring plant will receive one gene for color from each parent. The following table, which is often called a Punnett square, shows the possible combinations of genes received by the offspring. So parent 1 is on the side. They can give the capital G or the lowercase g. Parent 2, capital G, lowercase g. So I filled in the Punnett square. You guys are all familiar with Punnett square, right? Okay, good. So the Punnett square suggests that the expected ratio of green, which is both capital G's, to yellow-green, one of each, and albino, both lowercase g's, tobacco plants should be 1 to 2 to 1. In other words, the biologists predict that 25% of the offspring are green, 50% are yellow-green, and 25% are albino. To test their hypothesis about the distribution of the offspring, the biologists made 84 randomly selected pairs of yellow-green parent plants. Of the 84 offspring, 23 are green, 50 were yellow-green, and 11 were albino. Do these data differ significantly from what the biologists have predicted? Now, I put all that, and then I went, that's not enough space to do all the state plan, do conclude. So I restated the question back here with more space to show our work. Sometimes I do think ahead.
Good job.
Thank you.
Thanks.
Could I get a calculator?
Yeah. It only took you, what, 50 minutes into class, Hayden? Killing me.
Thank you.
Yeah. All right, so first thing, before we get into the state plan do conclude, at least myself personally, I need to actually, even though it tells us some of the data, I like a table, especially when I'm comparing observed and expected. So that's the first thing I'm going to do. I'm going to make a table over here that has my observed data and my expected data. And there are 3 colors the plants can be. They can be green, they can be yellow-green, or they can be albino. So they tell us the observed number. 23 are green, 50 are yellow-green, and 11 are albino. The expected, I'm going to flip back to where I put all the other information. The biologists predict 25% would be green, 50% should be yellow-green, 25% should be albino. So 50% of 84, that's where I started, in the middle, is 42. So we would have expected only 42 of the plants to be yellow-green. 25% of 84, 84 divided by 4, that'd be 21. 21 should be green, 21 should be albino. That's what we would expect. Now you want to try it on your own? Oh, come on, it's really not that hard. You guys got this. Thanks. Not according to Hayden, though. yesterday. He said I was a horrible teacher. Bad teacher. You didn't say horrible. I can't remember what adjective, but it was not very nice.
She gave you Skittles yesterday.
Yeah.
It's fake.
And then my husband stole all my extra Skittles.
How rude of him.
Yeah, he apparently needed candy for something in Intro to Psych and stole all my extra Skittles.
You're definitely a
That's probably
better
for him.
teacher than Mr. Bellsbury.
Well, that's harsh. Have you
Damn.
even ever had my husband?
Yeah, he was like the ACT test guy for me. I didn't like
That's not teaching.
Talk to anything in there.
It's not teaching. They threw us all like, okay, the day of the ACTs, this is what they gave us. That was them preparing us to do ACTs.
Oh,
The only snack we had was trail mix.
Yeah. And by the way, they put something incorrect on here, so then we all had to sign impropriety reports because they told us to do something incorrect. And what did we all do? We all follow directions.
What did they tell you to do?
They let the students out.
Pass the test booklets out. Put one on every desk, even if a student is not present. Well, that's what I said. And the two teachers I was with were like, that's what the directions said. And I'm like, I'm pretty sure they made this whole explanation about how you have to keep everything in order so that the test booklets stay in numerical order. And now we're breaking order because I just gave an empty desk a test booklet and they were like, that's what the directions say. And then they came in halfway through the test and they're like, don't do that. I'm like,
You should have just not done it.
well, I was outvoted. There are 3 teachers in every room, and the other 2 were like, but it says it. I'm like, it makes 0 sense though. Sorry. So they kind of didn't prepare us well. So judging my husband on that, kind of unfair. All right, state plan do conclude. You guys got this. Oh,
We need help. No, Miss.
state,
Yeah.
null, alternative, alpha. Didn't you say you were going to protest yesterday too?
Yeah.
I'll join
How'd
you.
that go for you?
I did that. Not well.
I think it went great for you. You got full credit on your homework.
Still protesting in my heart.
No, you would say that the 25, 50, 25% claim ratio is correct.
That's
And
the
then-
H1.
And then the alternative would be that it's not 25, 50, 25.
Can you just put the code?
Miss Will.
Sure. Like I said, you guys are much better with words.
Can I say the claim ratio is the same as expected?
Sure.
Yeah.
No, but
It says the law just made 84 randomly selected. Boom. Actually did some. Oh yeah, you're right.
She is.
Do I have to do like that curved lines?
It's not.
Yeah,
Distribution.
That's all I need.
Well, I'm sure you can wordsmith a little better.
Not very good.
TF.
Wait, is it gonna be basic information?
Okay, go.
Wait, do you want to make this mine?
Well, it should be the
That's
funky
what I was-
one. Would you like to print right now? It was so pretty.
It's okay.
The inverse linear, whatever.
Like that.
Yep.
I'm gonna transfer it.
Oh, let's get down on this. Right?
Where's Joe?
And then the conclusion.
And then you have to put it in the list. That's what she
Yep. TF.
He knows the significance.
Unless it says anything different.
Yes.
Actually, I would this
We have to write the contributor.
Can I
Who
go?
are you guys playing?
I want to play Sheldon.
At Sheldon?
No, we played at US Cellular at 2.
At 2?
Why do you play two?
That's getting close. He's got to go now.
Wait, of course
He's
it
getting
is.
late.
In the snow.
It's snowing?
It's going to.
But you guys won problems.
I mean, it's the only time the field is available. And I don't want to cancel the game, so we schedule it.
Why not just play in the rain, in the snow?
In
It
the
doesn't
rain.
change the game.
I hope there's no switch.
It
Slippery.
ruins the field.
So
Slippery.
incorrect.
Turf out there.
No, okay. We're not worried about like rain or snow, but US Cellular is completely booked. Other than that, too.
Right, but you said you don't play because it ruins the field.
Yeah, our field, so that's why we don't play Norm.
Oh,
We
yeah.
wouldn't want to use the facilities we have.
We
so
do when it's not raining.
Let's
when
pay
it's
a
not
bunch
raining.
of extra money.
Let's use taxpayer money.
I love the brilliant ideas this district
Bye,
has.
Miss Will.
Bye, Trey. Good luck.
Thank you.
What if we just got turf field too? You don't have everywhere to play.
We need a new.
We need a swimming pool. That's what we need.
We do need a
swimming pool.
Yeah, we
Or we
do.
put it
We could
down.
have a
So
pool
they're,
there.
they're,
Ex-
that new place, they're building.
That's what near,
out
I
by-
got 6 road to
Yeah.
Jackson.
Yeah. So,
It's like a big,
I'm sure some of you know my husband is very upset about how they ruined the soccer field out there. And he's been, they crowned it and they didn't crown it evenly. So it used to be flat and there was drainage issues where it would puddle up at corners and sides. So most soccer fields have it crowned less than 1%, which just means it's slightly rounded so that the drainage goes off to the sides. They keep it like 5% crown, so it's got this huge mound. And not only that, it's like here on this side and up here on this side.
Oh,
So you
no.
can't even see the feet of your like teammate from one side to the other.
No way.
Yeah,
that's great.
they totally messed it up. And they took it from regulation and they put those stupid cement pads and for the benches and they took the width down and it's not even a regulation soccer size, like soccer field.
The cheating, the playing.
Like I swear, they just put somebody in charge who had no clue about soccer fields.
And they got paid.
Yeah.
Yeah.
Anyways, so he's been asking the district, like, hey, can I raise money to get a turf field out there? And they finally were like, no, because when they build that new facility, that's where all the districts will do all their sports. There's gonna be a
Wait,
swimming pool.
There's gonna be a new facility?
There's
Yeah,
like
the city of
six,
Medford approved it.
6 or 8.
It's over,
It's a bill.
over.
Across the street from Walmart, right?
No,
No.
on the way to Jacksonville.
Do you know where?
It's like by
There's
the
like that
Hamptons,
firework
that
place
little-
where there
No,
was
there's
firework.
not, do you know where the bottle originates?
Yeah,
Yep,
it's
all
by
the
the
time.
house
Yes.
places.
Oh.
At the Hamptons.
Yeah.
But it's gonna be for all the Medford schools.
Like Ross Stanley?
Yeah.
Yes, yeah, you're
Is it
right.
next to Lola's?
Is,
No.
is that the
Yeah.
one that's out there?
Yeah.
Yeah, that's near Logos.
Okay, yeah. So, and there's gonna be a pool out there,
Yep.
but they said north and south will use that for home soccer games.
Yeah,
And
that's sick.
so they will not approve him raising money to get a turf field over there.
How come they do that when we're graduating? Why not?
Say that again,
Is it
sorry.
strong evidence?
They're lucky.
I did it.
Woohoo, good job, Anna.
Wait, how do you know if it's strong evidence?
Is your fee less than over or greater than over? I gotta get my stuff.
No.
Just give me pencils.
Okay, I'll get you a pack of pencils. What kind do you like? Did you see that? What's the, the really nice fancy paper pencils, not the ones that have the like paper ones, you know?
Assuming things that is true.
Paper pencils. You know what they
This
look
little,
like?
what's your favorite song?
I'll show you. They came
My
out with a yellow
favorite
one,
song
and I
right
want
now
it
is-
so bad. You do? They
like
came out with a yellow
silence.
orange one. No,
Like the
they
lead?
came out with yellow ones. Like
Literally
Twitter peppered it.
Oh.
I do like
I
Kate's
can't
song,
just-
Silence or Marshmallows, whoever it is.
I didn't
I
know
thought
this
she
was
actually
that.
did this.
There is a song, right?
Oh.
Lead. It's called
I think no one
Silence.
meant that you just like
But I
silence.
do
Yeah.
like that
Yeah.
one, but I just like, I never get silence. My 3-year-old talks
yeah, you have a 3-year-old.
non-stop.
The table.
I'm pretty sure that's
My mom
Shelby.
used to do that to me.
What?
Yeah, she did that. She's
Like,
not
then
as
I'm
funny.
not, like, taking my
You
foot to the
talk
pedals.
about this. Yeah, I know.
I mean, he literally, he just never stops.
You should give him that
I thought it was.
Just
No,
like
I
a
don't.
tower.
It was like a mutually agreed table, and I was fine because it was fake. You couldn't take it
My
up.
dad has something broken, but like, yeah, I think that's now.
This provides what?
That's so bad.
What is this for?
Strong?
No, I said strong.
Yeah.
Yes.
I asked her. I should get it right out.
Against what? This provides strong? No, it's still strong.
I don't like my grade and my grade because they right. Yeah.
H O. Yeah. Yes.
I don't
How
know
many
why
degrees
this
of
one is
freedom
like-
do these get?
Two?
Better have all like equal levels. This one is like a very
That's big.
So the
That-
body goes
So they're like, no.
That's big.
Yes, sir.
This little like kind of like eyes, and it's stuck in it. And I'm like, oh.
Therefore,
It's like I can't like get out of the hole. And there's like,
therefore,
they just came out with orange.
you reject.
And there's like
Yep,
that color.
just
It's like,
one more
H.
sentence after Laura's contribution.
why is that so funny? You have to write that.
Yeah. I mean,
Dude, imagine
And I
being
just said the
lost.
largest contributor.
Because this is in a chi-square.
I think it's like
There's
4.7.
I was gonna get you
And
those.
now
Oh,
final.
okay, you want the sparkly one or the dark?
Ratio.
because
Well, there's ones
you have
like
more or less than yours.
either way.
Don't you say the largest contributor?
Yes, you
Oh.
must have a sentence about the largest contributor.
Oh. We're all like,
The largest
oh shoot, I don't figure about it.
contributor
Just come up to me.
is
I didn't laugh, I was crying.
is
I
what?
think it's the
Is-
first.
Will you go skate party?
Is or
Anna's gonna skate for us.
Which is less than 4.7.
Yeah.
steak?
Endeavors.
Oh,
Is it
thank
really?
you.
Yeah.
Why are they so hideous?
I only got my paper.
Oh, oops, I'll fix that. But other than that,
Yeah. You're gonna plan.
oh, are we supposed to color it too?
You have to shade the little part, yeah.
Miss Whittle, I really like these pens.
Me too.
Where'd you get them?
Target.
Oh,
Target.
All my pens. I love Target.
Me too.
oh my gosh.
It's just a tiny little bit. Going here. That's part of why I like drop. Because I don't actually show it. It's just the tiniest little bit.
Yeah, I'm not. See, did I do
Yeah.
the eye?
Please do.
Bigger than one. Which is like, how did I get? Hold on. Wait, you need green.
Addie, you're up.
Okay. Addie got it.
Does it matter what color you use?
Just not green.
Okay.
Uses green anyway.
That would be something Maddie would do.
That's true.
I forgot to mark Jillian absent.
She'd be fine with that.
She would be. I'm hungry.
Me too.
That was not very nice. Thank you. Tyler's gonna do.
So old. Yeah. Dude, did you see after it? I was like, because it was too hot, so it was just. It was like. It was and then it got warmer and everything. Like, it was just like. Oh, so they like it was sunny at the same time. How was it snowing and wasn't it? I don't know.
Thank you, sir. And Hannah is going to conclude for us.
To make my handwriting presentable. Is it on the screen?
Thank you. Any questions? All right. On Thursday, we get to learn chi-squared test of homogeneity. I know, right? We get to use matrices. Matrices. So don't forget your calculators.